Take a network break. Help yourself to a virtual donut as we scan this week's tech news. I'm Drew Conry Murray.
And I'm Jonna Johnson.
And we got updates on CrowdStrike. We have an FCC analysis of an AT&T outage, some space networking and more. Last week's show spurred a bunch of follow-ups, so we're going to dig into your comments, but just a little business to get out of the way first. Today's sponsor is 1Password Extended Access Management. You can bring all your unmanaged devices, apps, and identities under control with 1Password Extended Access Management. Ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management is available now to companies with Okta and coming later this year to Google Workspace and Microsoft Entra. You can check it out at onepassword.com/XAM. That's onepassword.com/XAM. Stay tuned after the news. We have a Tech Bytes podcast. We're going to talk OpenConfig and data models with sponsor Nokia. Nokia's SR Linux Network OS has embraced OpenConfig to help you support automation initiatives. And we'll talk with Nokia about why it chose OpenConfig, how it handles mixed data models for device platforms that may or may not use OpenConfig, and how Nokia is using GRPC for streaming telemetry. Okay, so Jonna, last week we talked about Microsoft and CrowdStrike, and you made some Microsoft comments, and we got a lot of FU.
Yes, we did get a lot of FU, and it really ranges across the spectrum. So without further ado, here's a sample. Somebody wrote in, said, Jonna, I 100% agree with you about Microsoft's products being so incredibly weak that a single file can kill it. I've been saying this all weekend to anyone who will listen. I'm not in a position to have any commanding lead here, but if I were, I'd ban Microsoft products. And I just got to say thank you for the thumbs up. Not everybody feels the same, though. Yes. Somebody else wrote, and I actually really like this one. The Windows bashing on the recent episode of Network Break is misguided and immature. Windows was problematic in the XP days, but today it's a perfectly reasonable and secure OS. Well, I kind of think they're partially right. I will certainly take immature, talk to my friends. That's probably the case. I won't say that it's misguided is entirely accurate because, among other things, as I've noted in our other podcast, Heavy Strategy, Microsoft products were responsible for a disproportionately large number of vulnerabilities in the MITRE attack matrix. That's not my opinion. That's a fact. And it goes across all Microsoft, not just Windows as the operating system. Also, the Federal Cyber Safety Review Board actually found last year that Microsoft has inflicted a cascade of avoidable errors and has a security culture that requires an overhaul. Again, that's not me saying it. That's actually the Cyber Safety Review Board, and that was back in 2023. So I'll take the immature, and certainly we want to drill into some of the details of what actually happened here between CrowdStrike and Microsoft. But I do think there is a growing awareness that there are issues, cybersecurity issues with Microsoft.
Yeah, for sure.
And one of these I actually really liked. Somebody wrote in, hey, CrowdStrike is a low-level security tool with components running in the kernel. When you run in the kernel, there's no other failure mode. Everything you said was assumptions. Well, yes, but no. Yes, there were a lot of assumptions in there, but I've also spent an awful lot of time dealing with end users. So when I talk about things like their licensing strategy, those are facts. But the bigger issue is that, as we understand it, there was an input file in the CrowdStrike update that was empty and not expected to be empty ever, and CrowdStrike's driver just died. There are graceful ways to handle a driver that just dies. A robust kernel doesn't just crash. So what we have really is, yes, CrowdStrike is absolutely a fault for its lack of testing and brittle driver and bad processes, but you also have an OS that's not resilient in the face of something that should be a predictable error. Mm-hmm. Then there's somebody who I like his thinking or her thinking because they said respectively need to push back. I think he meant respectfully need to push back on Jonna's recommendation to ditch Microsoft. And the issue here is you got to consider the costs and risks to replace Microsoft in a mid-sized company. I've got 1,200 workstations, 500 servers, SQL databases, Teams, SharePoint, Azure. It's a lot. And I certainly agree with that. And I work with companies that have even more, tens of thousands of workstations, multiple instances of Azure and AD, which is a little wonky, but okay, and hundreds of servers. And I'm the last to say that it's ever easy. Right. But my suggestion is maybe it's time to start thinking about it. And at the end of the day, a carefully planned transition is a lot less disruptive than a crash.
Right. Yeah. If you are thinking about moving away from Microsoft or diversifying, you can plan it out. You can game it out. You can do it in stages so that you're not trying to do it all at once. Although I also do think there is something to, for a technical person to go to the business side of the house or a C-level person and say, we'd like to move away from Microsoft, and then being like, no, it's not going to happen. Too disruptive. So go away.
Exactly. And that is for real. And we do understand that. And I think the person that really best summed this all up, and I really loved this one, was this person writes, my take is third-party kernel drivers are always a risk because they get less testing and examination. CrowdStrike should have fuzz tested with their kernel drivers so any invalid input would not crash the system. Yes, they should have. Microsoft uses fuzz testing, and it's widely used for Microsoft for Windows and Linux. Linux has extensive hooks for monitoring, tracing, and admin via eBPF. These hooks all run in the kernel, but the code's virtual. So basically, Linux does it right. If Microsoft had provided similar hooks, this never would have happened. And then the recommendation that I think is the best and most insightful, drivers written in other languages like Rust are interesting but years away from being practical. But I love that recommendation. For those who don't know, Rust is a highly secure coding language that is really interesting the way it goes. It's very C++-like, but highly secure. And finally, this person sums up by saying, as several others have noted, highly integrated stacks like Teams and Microsoft 365 are what users seem to want and help sell licenses, but are a complete disaster. Dependencies suck, but having a huge attack surface makes everything insecure. And I just like to leave that listener with the last word.
That was a good last word and very accurate.
And so with that, I think we're ready to talk about, some of the more fallout on the incident, right, Drew?
Yeah, so that's the FU for this portion of the show, and FU is our follow-up here. And if you've got more comments, clarifications, or you want to just jump into the conversation, packetpushers.net/FU. We do love to hear from you, and we will respond. But yeah, we've got more details on CrowdStrike. The company is now saying that a flaw in its testing software, it's called a content validator, allowed a problematic update to pass validation checks. CrowdStrike released a preliminary post-incident review that says in part, quote, problematic content in channel file 291 resulted in an out-of-bounds memory read triggering an exception. This unexpected exception could not be gracefully handled, resulting in a Windows operating system crash. CrowdStrike says going forward, it's going to add more testing to software updates, including fuzzing, as the listener suggested, and use a more staggered deployment of updates, including a canary deployment to make sure to see if software updates are having an adverse effect before they send it off to millions of clients.
And I know there's links that you can check on to read up on this in greater detail, but it's also worth noting that CrowdStrike's current CEO, George Kurtz, was also CEO of McAfee during an infamous 2010 update that caused several PCs to also be stuck in an endless boot loop. This quite likely makes George Kurtz the first CEO in history to preside over two major global PC outages caused by bad security software updates. Not an award I would want to get. And
it wasn't several PCs; it was like several thousand PCs,
yes.
right? Or
yes. It was like large numbers back in 2010. So, gosh, almost 15 years ago now. And we have that link as well on the side. So,
yes, definitely not the feather you want in your CEO cap. Sticking with CrowdStrike, Fortune 500 companies could lose an estimated $5.4 billion due to the CrowdStrike Microsoft outage. That's an estimate from the insurance company Parametrics. The company says the healthcare and banking sectors will take the largest losses collectively at 1.9 and 1.1 billion, respectively. But by individual companies, airlines are likely to eat the biggest direct financial loss at an estimated average of 143 million for each of the 6 airlines in the Fortune 500. Parametrics also estimates that only 10 to 20% of those losses will be covered by cyber insurance policies.
And but CrowdStrike, all is not lost because CrowdStrike is giving a $10 gift card issued to employees and partners that have suffered. So aren't you happy you're getting your $10 gift card, which I believe also people have found doesn't work?
Yeah, I guess so many people started using the gift cards that the Uber, I think it was like an Uber Eats card, and Uber was like, what's going on here? This must be some kind of a DDoS or something, and stopped honoring the cards. So
it's a cybersecurity incident. Oh my gosh.
CrowdStrike cannot win.
Right. Well, yes. Moving on from bashing CrowdStrike and Microsoft, let's go bash the phone company. The FCC report blames February's 12-hour AT&T outage on, wait for it, bad change management. Supposedly, an AT&T staffer pushed a network element featuring an apparently unreviewed and untested configuration. Gosh, this is sounding very familiar. Into their production network during an overnight change window. Propagation of the misconfiguration to other elements in the network over the course of the ensuing 3 minutes triggered high-level management automation to go into protect mode and disconnect everything from the network to prevent the infection from spreading further. It took only about 2 hours to fix the original problem, but it kept on going for another 10 more hours after that, affecting 125 million customers and 92 million calls, including at least 25,000 911 calls, which is never good. You can read up more about that here, but I don't know. Drew, do you have any thoughts on this one?
The FCC put out this post-action report, and I was like, this happened in February, but I have no memory of it. And I think it goes to show the kind of environment we're living in where AT&T can knock out service to 125 million customers, and you just kind of forgot.
Exactly. And I will just highlight the fact that, improper change management is the root cause of both of these outages. And, I don't know. I think back when they were building the pyramids, people understood the impact of improper change management. So I don't know why people have to relearn the same lesson over and over again, but I guess that's just human nature.
Yes, although I'm sure AT&T is kind of happy about the CrowdStrike Microsoft thing because this may have gotten more play, but that sort of pushed this news sort of right off the map. Like, don't worry about our February one. Think about this one.
Exactly, except for us, because here we are with the facts.
And Johnny, you've also got some thoughts on the NTIA coming out with they've got a proposal for BGP security, but there are issues here.
Yeah, exactly. So very recently, NTIA is advocating for FCC requirement to provide reports on route origin authorizations. They're basically saying if you go and read the link that we've included, go fix BGP and make sure that you automate the non-propagation of bad BGP data, which is all well and good if it weren't for the fact that back in 2015, the IETF, the Internet Engineering Task Force, came up with RFC 7454, which specified exactly how you can secure BGP going forward. It's now obsoleted as of, today, as a matter of fact, with an IETF draft spec that talks about how to take this into the future. So my big response to the FCC requirement is that's fantastic, but it would be nice if the FCC simply said, we have a standard, go follow it, because that would have made things a lot better 15 years ago, and we still have the opportunity to make it better now. So basically, all the government needs to do is mandate support for the RFC 7454 successor spec when it is finalized, and we're done. Hopefully, that will happen.
So it's the National Telecommunications and Information Administration. They're asking the FCC to step in and take action on this?
Yes. And they're basically saying we want to improve BGP by taking these several steps, and none of the steps involve actually using secure BGP. Okay,
so they're essentially reinventing the wheel.
Exactly. Okay. And not making it any easier for carriers who wish to actually implement, or carriers or large enterprises who actually wish to implement secure BGP, because of course, everyone has to be supporting it.
All right, we'll pause for a brief message from sponsor 1Password. Imagine your company's security is like a college campus quad. There's well-maintained brick paths between the buildings. Those are your company-owned devices, IT-approved apps, and managed employee identities. And then there's the paths that people actually use, like the shortcuts through the grass, around the fences, and behind buildings. These are your unmanaged devices, shadow IT apps, and non-employee identities like contractors. Most security tools only work on those nice brick paths, and a lot of security problems take place on the shortcuts. 1Password Extended Access Management brings all these unmanaged devices, apps, and identities under your control. It ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management solved the problems that traditional IAM and MDM can't touch. It's security for the way we work today, and it's available now to companies with Okta. It's coming later this year to Google Workspace and Microsoft Entra. You can check it out at onepassword.com/XAM. That's onepassword.com/XAM.
In other news, network vendor Arrcus nets $30 million in new investment. The startup, which provides a Linux-based data center switching and routing OS, a multi-cloud networking solution, and management and analytics software, has raised $30 million in a post-D round of funding, continuing to pursue market share among high-end enterprises, telecom providers, and hyperscalers. The investors include Lightspeed, Prosperity 7 Ventures, and Nvidia. What do you think about that, Drew?
And so I feel like Arrcus came to market at a time when disaggregation was kind of like the flavor of the month, or it had its 15 minutes of industry fame. And the idea is that you separate the network OS from the underlying hardware. I think Arrcus is focusing on carriers and cloud scale orgs. As you said, it's got a disaggregated router. And I think that their contention is they can get away from sort of the constraints of the big chassis designs that they use merchant silicon and CPU to support routing functions that are sort of like Lego building blocks that you can easily scale.
Yeah, it seems like things are going well with them. And I think I'm particularly interested in Nvidia making that investment because I think they're looking ahead at future, support for AI. And just a side note that this sparks in my brain, a number of clients and enterprises have been asking about the appropriate architecture for AI. So that tells me that people are really thinking about how to bring AI in-house or how to spread it across data centers and clouds. And obviously, Arrcus is thinking along the same thoughts.
Yeah, so there was a flourishing of, various disaggregated NOS flavors. A lot of them ended up getting kind of parked in the Linux Foundation. There's also Cumulus, which got acquired by Mellanox, and then Mellanox got acquired by Nvidia. So it was interesting to me that Nvidia was also interested in Arrcus, but it looks like Arrcus is partnering with Nvidia to put the Arrcus NOS on the Bluefield DPU, which I think is an interesting play.
Why? Why do you think it's interesting?
Well, for one, I'm thinking you've got Cumulus. If you're looking to get a network operating system on a DPU, you have one in-house, but I guess maybe they want to, if a customer is already on board with Arrcus, they want to support other NOSes on the DPU.
Yeah, that's an interesting strategy for NVIDIA. So anyway, worth paying attention to.
Yeah. We've got some financial results from Juniper Networks. They reported the financial results for the second quarter of 2024. Revenues were $1.2 billion, down 17% versus last year. Net income was a brighter spot at $34.1 million, up 40% this time last year, and better than Q1 2024 when Juniper lost income. Although revenue for all three business units, that's WAN, data center, and enterprise campus and branch, they were all down compared to Q2 2023. The one bright spot was hardware maintenance and professional services, which did beat last year's revenues.
Well, and of course, my immediate thought reading this was, it's the pig in the python effect. We've talked about this previously, where a lot of people put in orders for hardware during COVID that couldn't be fulfilled due to supply chain issues, and now they've gotten them. And, CEO Rami Rahim said in a press release quote that essentially we saw particularly robust orders from our cloud customers, which have digested prior purchases, which makes me think he's thinking along the same lines.
Yes.
And the second thing, as I mentioned earlier, are investing to support AI initiatives, which I believe is very much true. And he also notes that the Juniper expected better than expected enterprise demand due to continued momentum in the Mist-led campus and branch business, and also enterprise data center offerings, which interestingly, a significant percentage of workloads are still on enterprise data centers, something that we're finding as we go through our research. And just a reminder that Juniper is being acquired by HPE for $14 billion, and that acquisition is expected to close at the end of this year or early next year.
Yeah, and Juniper said that because of that acquisition, they aren't offering any guidance, forward-looking guidance on future financial results. I'm curious about how revenues can be down 70%, but net income is up 40%. That doesn't really track for me, but Juniper managed to pull it off.
Well, it's one of those things, they cut costs somewhere, I guess. But I do remember them laying off. Actually, now that I think about it, I think Juniper had a couple of waves of significant layoffs, significant because they were laying off some of the more seasoned engineers, the more senior engineers, and the more expensive engineers.
Yes, and some executives too, yeah. Some folks.
Yeah. And exactly. And so, I remember noticing that a couple of my friends got caught in that one. So
yeah. Friends of the show for us too. And you've got a note from Cisco on vulnerability.
I do. So Cisco is speaking of companies that have gotten caught by cybersecurity vulnerabilities and then companies that proactively fix them. Cisco announces that it's fixed some high-risk vulnerabilities in its secure email gateway and smart software manager. If you want to go look them up, they are CVE 2024-20419, and these allow remote unauthenticated attackers to change any user password in the system via HTTP requests. However, Cisco points out that it knows of no actual attacks built around this vulnerability. It also knows of no workarounds to mitigate it, so it just went ahead and fixed it. What a concept. So if you're running those Cisco products, you really want to implement those patches. They also released patches for the secure email gateway appliance to fix CVE 2024-20401, which is a vulnerability that would allow attackers to permanently crash appliances using specific kinds of malicious attachments to an email. So once again, if you are paying attention to your Cisco security patches, now would be an excellent time to implement them. There are no workarounds, just fix them.
Yeah, sometimes it's good to have a workaround if you've got a patch window or a regular maintenance cycle that you're trying to work in. But with the fact that there are no workarounds, you just have to patch it. Yep.
So if you hadn't heard about it now, you've heard about it here. So please take action.
Yeah, and links in the show notes.
And Drew, you wanted to talk about Starlink, measuring Starlink performance versus traditional ISPs.
Yeah, so this is our space networking series. We started this with Greg. We like to get a little space networking to the show. But academic researchers say that the satellite-based internet service from Starlink is competitive in performance with many terrestrial-based ISPs, particularly in the United States, which probably isn't hard to guess. Outside the U.S., Starlink fares less favorably in comparison with traditional ISPs. The researchers analyzed speed test measurements from 34 countries and did controlled measurements from terminals in 2 European countries. They also measured real-time Zoom calls and cloud gaming. They did find that in geographies such as Rome and Paris, Starlink had higher latency than terrestrial ISPs, which the researchers attribute to a smaller number of Starlink POPs that connect ground stations to the internet.
Well, and I think this is interesting because I've been saying for a while that this would be the case. A couple things to focus on. One is one of the problems with ISPs in the U.S. is we are simply so darn big. Remember that we are, 3,000 miles from end to end, depending on which way you draw your lines. And in Europe, you're lucky if you have a country that's 300 miles end to end. Sure. So, the distances are very different. So you can see that something like Starlink is actually going to do very well with latency. What stands out in this, though, to me, is that they actually analyze speed measurements and actual applications, which is kind of the gold standard in some respects, because you can say that hypothetically, blah, 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 woof, 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 but they're talking about real-time Zoom calls and the most demanding apps, cloud gaming. And that's actually a really big deal. So I think the question that bubbles up is, does that make Starlink actually a viable competitor to terrestrial ISPs? And that, of course, will come down to fundamentally cost. It will have to be a lot cheaper in order to be truly competitive, is my read.
You think so? Because I feel like, well, maybe it's just me, but people get so frustrated with their current crop of ISPs that even if Starlink was only slightly cheaper, they might be like, yeah, I'll give this a try. And if it works great, then that's fine.
You know what? You're right, Drew. Having just had a battle with my ISP, if there were any other options up to and including Starlink, I would actually pay them more just so I wouldn't have to deal with this company who shall remain nameless.
Yes.
But then again, I'm also a sailor, and I really would like to have Starlink up and running on boats, because when you're out there in the middle of the ocean, it is really nice to be able to tap into the internet sometimes. We're not quite there yet, but we're getting very close. It's certainly some of the more advanced sailors are out there with Starlink, but it's not as widespread as I suspect it will become in the next few years.
Yeah, that's a great use case. And again, aside from getting service to underserved areas, particularly in the U.S. where we don't have great coverage by some ISPs, and because we are such a big country, the fact that Starlink can bring service there, I think, is also going to give it an advantage. The report did note that there still can be significant fluctuations in Starlink performance. They presume it's caused by handovers of connections between satellites that can degrade performance. Although the overall conclusion is Starlink, yes, is a viable competitor to terrestrial ISPs, although they do say to be more competitive, they anticipate that Starlink is going to have to make further investments both in the satellites that they've got in orbit and their ground-based connectivity. So pretty good start, though, for Starlink. I think they've got like 4,000 operational satellites in space, and if they're already performing about as well as at least U.S.-based ISPs, I'm frankly kind of impressed.
I am too, and I think this is positive, and I think there'll be a lot more to report on our space networking.
Yeah. All right. That wraps up the news portion of the show. Again, if you have comments, corrections, clarifications, you can always hit us up at packetpushers.net/FU. We do love to hear from you, and we will respond in the show. Please do stick around. We're going to be talking with Nokia about their use of OpenConfig in their SR Linux network OS. That's coming right up. Today on the Tech Bytes podcast, we talk OpenConfig and data models with sponsor Nokia. Nokia's SR Linux Network OS has embraced OpenConfig to help you support automation initiatives. We're going to talk with Nokia about why it chose OpenConfig, how it handles mixed data models for device platforms that may or may not use OpenConfig, and how Nokia is also using GRPC for streaming telemetry. Our guest is Igor Giangrossi, Senior Director of Consulting Engineering at Nokia. Igor, welcome to the podcast. And just for listeners, can we get a quick refresher on OpenConfig and its role in network automation?
Sure. Thanks, Ethan and Drew. Glad to be here again. OpenConfig is a project that was primarily created by some cloud providers and some telecom operators to help automating networks. And the goal is to provide normalization of data models and also create some interfaces or APIs to talk to the network devices. So then it becomes a vendor neutral and a device neutral way to communicate and operate with those devices. An example of that would be you have multiple vendors, multiple devices in your network, and you can configure, for instance, an interface in exactly the same way for all your network devices. An important point of it is that it's an open source project and it's not necessarily a standard through a standards body. So that difference is key because typically when you go through a standards body, they try to create a standard that covers all bases and all corner cases. Whereas when you look at an open source project, the goal is essentially to fulfill the members or the community needs. So that's the target that OpenConfig takes to see what the community needs and push that forward.
So does that mean then, as Nokia, you are thinking about the needs of your customers and maybe data center operators in particular for this use case?
Data center for sure, but not only data center. There are actually a few large telecom operators that are part of the OpenConfig community that also push their use cases there. And their use cases are more like WAN or service provider, if you will, type networks. So it covers a very broad base of use cases.
And just sort of another high level question, why are data models and having uniform data models important for network automation?
If you look at a network automation goals, everybody will have a little bit different, but we can probably agree that you can come down to having machines managing your network and using some predefined processes that are repeatable and very well controlled. And the benefit of doing that is it allows the networks to scale more easily. It will bring some operational efficiencies, reduce human errors, be more agile, and even save costs. So in order for those machines to talk to these devices, you will need a language or an API. And if you really look at it, the CLI was the only API available from the beginning. And all of the networking automation projects in the past started using CLI. So essentially doing CLI scraping, where you would issue a command, get the output, and parse that output. Obviously, lots of challenges there because the CLI command might change. Even if the CLI command doesn't change, the output might change slightly. The formatting might change. Parsing those characters might be hard. You need to know what's a string, what's an IP address, the length, and things like that. So it was a very hard way of doing it, but that's how most people started using the CLI as an API. And that's where data models become important, because if you want to be really efficient in the way you have machines talking to network devices, you need to provide a well-structured or well-defined structure for all of the data that is available in a device in a format that can be consumed by the machines. And there are many ways in modeling that data. Yang is actually the language that is mostly used for networking data models. And that just makes it easier. If you can interact more easily with the devices, then you can much more easily build a networking automation system around it.
So with the need to choose something to do your modeling in, you ended up with OpenConfig, Igor, but for some that's going to be a controversial choice. There's plenty of people who have negative things to say about OpenConfig. So maybe you can explain why Nokia chose OpenConfig and then some of those challenges that go along with that choice.
Sure. And that's a great question. So let's start with the first part, which is why OpenConfig. And I'll just start by saying that obviously we do have our own native model as well as not only OpenConfig. So maybe the question will be, should we add OpenConfig to SR Linux or not? And our goal with designing SR Linux was to design the most modern operating system we could. That reflected not only in the internal architecture, how we built the system itself using cloud native principles and so forth, but also we had to put a major focus on network operations and how we would be operating networks into the future. And that means network automation. So the focus on network automation became very obvious. So the way we design it is we started with a model-driven foundation. So we said, no matter which model we use, 100% of all of the configuration, state, and operational actions must be available using some data model. And obviously, we developed a data model, a native Nokia data model, took over 100% of all of these. And this applies to every single process running in, or applications or services running in SR Linux, either developed by Nokia or even third-party applications or agents. And then we had OpenConfig, and we decided it was very important for us to treat OpenConfig with equal importance because we saw an increasing demand for it in the market. So it is a polarizing topic. Some people have had different experience with that, but there are a few large companies, and some of them are cloud providers. Some of them are large telecom operators that are actively pushing the industry to move towards OpenConfig. So we saw that demand, and we decided to take the OpenConfig support into SR Linux to the next level. So what we did was to make it easy to consume as many APIs as we wanted, and as many data models as we wanted throughout the system, the SR Linux OS. So not only we adopted the OpenConfig data model, but we also started to adapt the GRPC-based processes that are the APIs derived from OpenConfig. So GNMI, GNOI, we can talk about these as well. So that is another major focus of SR Linux, to be able to provide any API so that we can actually integrate into any existing network operations or automation environment. So that was an easy decision as well. And then we also started contributing to the OpenConfig community, where we developed a client for GNMI. We call it GNMIC, and we actually donated the code as open source to the OpenConfig project so that anyone can start very easily testing and implementing GNMI through this API into their projects.
But importantly, OpenConfig here is additive. That's a key point. It's not just that you support OpenConfig; it's that you have your own full data model that fully describes SR Linux, and in addition, you're supporting OpenConfig, which connects you to that ecosystem.
Yes, that's correct. And that goes back to the second part of the question that you asked before. What are the challenges? So the main challenge of OpenConfig being a community-based or community-driven project in an open source project is that whatever the members want or whatever use cases the members want to adopt or develop will be what's supported. So if you have a use case where some of the use case or all of the use case is not supported by OpenConfig today in their data models, you cannot use it. Because there's been a large push and a very large expansion into support of many different protocols and use cases within OpenConfig. It has evolved to a very good place today, but there might still be some situations where you're not going to find some specific things into the models. And a good example of that is any innovation that any vendor or any special knob that any vendor like ourselves will put into any protocol, right? So you can have the base protocol support, but then let's say in protocol XYZ, we create some special configuration that allows you to do some special things that might not be covered by the OpenConfig model. So in that case, you'd have to configure using the data model that is native to that network device, in our case, the SR Linux native model. And we wanted to make sure those two situations were fully supported simultaneously within SR Linux.
Okay, so you're saying in a mixed model environment, Nokia can still handle OpenConfig, Nokia's own data model. Are there others that you can deal with?
Right. So we have our own data model, and we have the OpenConfig data model, and a big design principle was to support them or simultaneously or have them coexist. So we have a single shared database that is always written into the we have a single shared database that is always written and read using the native data models. So everything that gets written into the system or read into that database from that database will be in native data models. And we created a stateless translation layer between OpenConfig and the native data model. And that stateless translation layer also allows for transformation in case our native data model has the data using some different formatting than what the OpenConfig model needs. So we provide those transformations as well. So that translation layer is fully configurable, so you can actually see what are the exact mappings between the open config paths and the native model path, so that becomes very easy for you to understand what we're doing. We fully expose that. And when you write or read into OpenConfig, the OpenConfig agents internally in the box will go through the transformation and will write back or read from the database into the native model. So that guarantees that there is no duplication of state or configuration. Any commits in one model will be automatically reflected in the other model. So that makes coexisting those two models very easy and very scalable. Another example of that is the CLI. So the CLI navigation in SR Linux is built from the YANG paths in the data model that you're using. And you can actually choose whether you want to use the native data model for the CLI paths or you want to use the OpenConfig data model for the CLI as well. So that provides very good flexibility for you to develop and understand and operate in both models simultaneously.
It feels like that's a translation layer as opposed to an abstraction layer. Is that fair?
Yeah, that's fair. That's exactly what it is.
So Nokia, you guys are also offering support for GRPC. So we should remind people what that's all about, Igor.
Sure. GRPC is a protocol designed by Google for RPC. RPC is remote procedure call. So it's a fancy way of saying I have two processes that I need to exchange data or information between them. That's RPC. So Google developed their own protocol for doing that. It's also an open source project, so you can actually go and contribute to the project. A little bit more details on it for the technical folks. It runs on top of HTTP2. It encodes the data in a binary format that is known as protocol buffers or protobufs that will handle all the data serialization, or essentially how you get the structured data and send that through the wire. So it uses a binary format, which will provide some native compression. That is a good advantage against, for instance, some other interfaces that use text or XML based information, especially if you're dealing with very large quantities of data. And also has some tools for managing compatibility, both backwards and forward compatibility, which helps a lot when you're evolving your system and especially evolving the data model. So it has embedded support by that. Finally, there's very good support in terms of programming languages for gRPC. You can today pretty much use most of the big programming languages to write software using gRPC. So you take Go, Python. I think those are the two more networking oriented programming languages nowadays. But you can also use C, Ruby, Java, and many others as well.
So when I think about gRPC, I guess I think a bit about it in the context as an alternative to SNMP. Is that a valid way to frame it?
So gRPC essentially is just the protocol to exchange information. The alternative to SNMP would be how we use gRPC to exchange network management information. And that's where we go into GNMI. So GNMI is a protocol, is an interface called the Network Management Interface that is used to send and receive data between some sort of controller and network devices. So, for instance, that's how we provide streaming telemetry. And that's also being developed by the OpenConfig project, GNMI. So that was the very first interface. And then the OpenConfig project started developing other interfaces for other tasks during the life cycle of a network. So the first one was GNOI, so Network Operations Interface. It provides us the ability to run remote operational tasks. For instance, we can do a ping, trace route. We can do software upgrades. And remember that these interfaces are meant to be multi-vendor or vendor neutral or even data model neutral. We don't need to use the OpenConfig data models. You can use the device native data model. So for instance, for GNOI, you could use GNOI to do a network-wide software upgrade, and that would be done in a multi-vendor network, multi-device network through a standardized process. So that's the value right there. right? There's still another one that is a little bit more recent that is called GNSI, which is Network Security Interface, and that will provide security functionalities, as the name implies, authentication, certificate management, and things like that. So that's where we actually take gRPC as a fundamental protocol for exchanging information and take it to a use case level, either for managing network devices, the operational tasks, or the security tasks.
Yeah. Okay.
Igor, concluding thought here would be apply this for network engineers that they're seeing the benefit. That is, I could, as a network engineer, just go, Igor, the old ways are fine. I don't need your fancy gRPC, and I don't need open config models. I can just keep configuring the network the way I've been doing it for 20 years. And I'd be wrong. But would you explain why I'm wrong?
Yeah, absolutely. I think there's first a bit of a paradigm shift in the way we manage networks. So the SNMP model in the past had lots of challenges. So there were some standardized MIBs, but then when we go into enterprise MIBs, the situation is not so different than what we have today with OpenConfig, right? So there's varying degrees of support there. It's also an approach where you have a controller asking the devices, hey, send me this information, and the device would react and respond to that ask. So if you have a very large network, it becomes very difficult to scale that model. Nowadays, when we move to those data models with Yang and those types of interfaces, such as the ones we described here, for instance, GNMI, we can start to move from a paradigm where instead of a controller asking for information and getting all of that information back, where you might get relevant information, you might get just the same values as the last query. You can actually have your network devices stream information on demand. And yes, you can still do queries whenever you want, but by having that capability of pushing information on demand, you actually are sending just information when it matters. And it's a model where the devices push that information to a controller. The controller simply needs to receive that. So it's a little easier to scale to large amounts of data. So that's a little bit more modern way of doing this, and it will allow you to scale much further. That's the real benefit with those interfaces, as well as making it a lot easier to digest that data, because that data comes into I would say a more friendly format. Some people will say that Yang is not friendly at all, but at least it's defined. I'd say probably a better way of describing is a more defined way or standard way of looking into that data, so that you can ingest that data and do whatever you want with it, right? So I think that is the biggest advantage. And then if you can easily model each of those data models into your automation system, then you can start to abstract a little bit of the individual particularities of all of these network devices and go one level higher, which is really go to the intent level. So what do I want to do? I want to add a server. I want to add an interface into the network, right? And I don't need to go and look at specifically which of those devices are going to be in that specific compute, in that specific rack. You can start creating abstraction layers that allow you to focus on the intent rather than on specific configuration. And we are at Nokia also working not only on these approaches where we provide the data models and all of the GNMI, gRPC based interfaces, but we're also working on some software layers where we solve that in other ways. If solving that through the software controller is your way to go, we're also working on that. But I think that's a topic for another day.
Well, Igor, you're obviously very passionate about this topic, and we'll have to have you back so we can get into more detail. But this was, I think, a good intro to what Nokia is doing with OpenConfig, gRPC, and others. And if you're curious on what you can do with it, just head over to learn.srlinux.dev. That's learn.srlinux.dev. We'll also have other links in the show notes with more details, including other episodes that Nokia has done with the packet pushers and some technical blogs from Nokia to help you get your head around this. Thank you for listening. You can find this and many more fine, free technical podcasts and our community blog. It's all at packetpushers.net. You can follow us on LinkedIn. You can hear us on Spotify. And if you would, leave us a rating on Apple Podcasts, that would be great. And last but not least, remember that too much networking would never be enough.